Assalamu alaikum guys. We're gonna review waves today, and what we did about waves is very basic and very fundamental and very easy, super duper easy really. So what is a wave? A wave is just a disturbance that carries energy with it, okay? So a wave is a disturbance that carries energy with it. We have two types of waves. We have mechanical waves, and we have electromagnetic waves. Okay, this is not going to be enough. Magnetic waves. So we're going to talk a little bit about mechanical waves. We're going to talk a little bit about electromagnetic waves, and I'm mainly going to talk about what is important to you to do those simple calculations that you will be asked to perform on your tests. So let's talk about mechanical waves. Mechanical waves, they require a medium to travel. Or instead of using travel, we could use a fancier word, which is propagate, to propagate. And the example that comes to propagate, okay, this is the way you write it, good. Imagine yourselves as people who can live in a vacuum. Okay, that's not possible, but just imagine for a moment that you could live in vacuum. Do you think you could talk to each other and you could hear each other? Just imagine. Put your hand in front of your mouth when you're talking. You feel that the air is vibrating. You feel those vibrations. If you remove this air, the sound will not be able to travel, will not be able to propagate. So sound is a type of mechanical wave that requires a medium to travel. So no medium to travel, no sound. As simple as that. So if you are watching a movie, a science fiction movie, and then spaceship A bombards and attacks spaceship A, and then spaceship B explodes, so there's an explosion, and then you watch the inhabitants of spaceship A clapping because they heard the loud noise or the loud explosion of a spaceship B. What's the problem with this? You're in space. Okay, is there any air in space? Is there any... there's no medium, so that is a huge mistake on the part of the filmmakers who made a movie where the inhabitants of spaceship A would hear the explosion of spaceship B. I hope you got it. So sound, so if I want silence, then maybe I should live in vacuum, but that's not possible, so I have to deal with noise. Okay, that said, electromagnetic waves, these, they do not require a medium to propagate. They do not. So you see all the light that we receive from the star, from the sun. They travel, and then they travel at a very high speed. We'll talk about that a little later, but the electromagnetic waves, they do not require a medium to travel or to propagate. However, mechanical waves, no medium, no travel, okay? They stay home. There are no trips for them. Okay, Now that we have done that, I'm gonna tackle some types of questions that you will have on the test. So if you are given something like this, okay, so they will ask you, for instance, to what is the wavelength? What is the wavelength? Okay, and the wavelength, we use a Greek letter. It's called lambda. It's just, you know, some of the students in the class, they were saying, oh, it's an inverted Y. So yeah, I like that. It's just, this is the wavelength, and it's a distance, so it's going to be measured, you guessed it right, in meters. And then you will be asked to calculate or to see from the graph the amplitude, okay? And the amplitude is also a distance, so it's going to be given by in meters, so A and then meters. Let me start by the talking about the amplitude. So the amplitude, you see the peak, this is a peak. Here and here you have a peak, and here you have a peak, and here you have a peak. So the peak to peak distance, the peak to peak distance, this peak to peak distance, you take that peak to peak distance, let's say you have 2 meters, and then you divide it by 2. So the amplitude is going to be here 2 meters, peak to peak, divided by 2. That will give you 1 meter. So again, I need somewhere to write. So I'm just gonna write here amplitude. Amplitude is going to be peak to peak divided by 2. So I hope that you got it, just 2 meters divided by 2. And then the wavelength, you see how many wavelengths you have here, and I might explain in details, waves in details later on, but for now, for your test, I have here 1, so I return to the exact same point, and then I'm going in the same direction. This is 0 here, but the direction is going this way, so this is half a wavelength. This is a wavelength. So how many of them do I have here? 1, 2 wavelengths. So if this distance here is given to you to be, let's say, just a number, you know, 7 meters, for instance, 7 meters. So your lambda, the 7 meters, they represent how many lambdas? They represent 2 lambdas. So 1 lambda is going to be this 7 meter divided by 2, which is going to be 3.5 meters. Okay, so you could also find the lambda from here to here. This also represents a lambda. From here to here, this is also 1 lambda. From here to here, this is 1 lambda. So there are so many ways of finding the lambdas, okay? And you have seen this is super easy, so you cannot complain and say, oh, the exam is so hard. These are very, very simple calculations that you are going to be asked to perform. So we have seen lambda and the amplitude, so the wavelength and the amplitude. And now I'm going to talk about frequency and period. Frequency and period. And period. In general, just not just for this chapter. So let's say I am here. This is Safa. Okay, and this is Al-Marwa, and I'm performing Umrah, inshallah, soon. Then if I go from Safa to Marwa, this is not 1 cycle. I need to go back to Safa to complete 1 cycle. The time to complete 1 cycle, that time represents what we call the period, or what we denote like this by a capital T, and it's measured in seconds. I am not very, very fast, so it's gonna take me minutes to go from Safa to Marwa and then from Al-Marwa to Safa. So that would be the period in seconds. period. So this is the definition of period. The period is the time for you to complete one cycle. If you are going around the circle as well, the period is going to be the time to complete a cycle, to go around that circle once. Now, this is the period. So, and then the frequency. So the period, we said, what was the period again? What was the letter we used? It was T. And then it is measured in second. And it is what? It is the time needed to complete one cycle. Okay, the frequency now, the frequency, I'm going to use another color, the frequency, and we use the letter F, frequency F. We're gonna see about the unit. It is the number of cycles that you complete. Okay, I'm not gonna say you complete. The number of cycles completed in 1 second, So the period is the time to complete one cycle. The frequency is the number of cycles completed in 1 second or per second. Let us take some examples because I really want you to see the relationship between the frequency and the period. It is, as you guessed, of crucial importance. Okay, so let's see. Okay, so imagine, okay, so this is the period here, and then this is the frequency here. I complete one cycle in 2 seconds. I complete one cycle, okay, in 2 seconds. How many cycles do I complete per second? Do I complete a cycle? No, I need 2 seconds to complete a cycle. So how many cycles? Is it 1 full cycle that I'm going to complete in a second? No, it is going to be half a cycle. So the frequency is going to be 0.5 cycle per second. Imagine now that I complete a cycle in 1 second. So 1 second, I complete one cycle. It means that the frequency is also 1. If I complete, now I'm getting faster and faster, okay? If I complete a cycle in 0.5 seconds, I complete a cycle. So how many cycles do I complete in 1 second? 0.5 seconds is 1 cycle. Another 0.5 seconds, that gives me 1 second. So in 1 second, I completed 2 cycles per second, 2 cycles per second. Imagine now that I'm getting faster, okay? So 0.25 seconds, a quarter of a second, this is a quarter of a second. I'm going to complete a cycle in a quarter of a second. How many cycles do I complete in a second? You guessed it, you're right, 4 cycles. So if I complete in half a second, I complete 1 cycle. It means in 1 second, I complete 2 cycles. If in a quarter of a second, I complete 1 cycle, it means when the second is over, I would have completed 4 cycles. Okay, so you could refer to this later if you want, but I'm just trying to show you that I'm getting faster and faster and faster, okay? So this is the period in seconds, and then this is the frequency, and then we'll come back to the unit later. This is 2 seconds here. 2 seconds, 1 second, half a second, a quarter of a second, 1/8 of a second, okay? Oh, I'm getting really fast. 1/16 of a second. So we saw that here, if it takes me 2 seconds to complete a cycle, then the frequency is going to be half. is going to be 0.5. I complete half a cycle. If in 1 second I complete one cycle, then the frequency, since it's the number of cycles per second, is just going to be 1. If my period is half a second, so half a second, one cycle, another half a second is another cycle, so 2 cycles, you got it. And then if in a quarter of a second, I complete a cycle, so a quarter of a second, one cycle, another quarter, one cycle, another quarter, one cycle, and a fourth quarter, one cycle. So I would have completed 4 cycles. If in an eighth of a second, 1/8 of a second, I complete a cycle, it means I would have, in 1 second, I would complete 8 cycles, you got it? And then if in 1 second, if in 1/16 seconds, 1/16 second, I complete a cycle, it means when the second is over, I would have completed 16 cycles. I want you to see this. See, this is a 2 that is here upstairs, but I have 1/2 for the frequency, 1, 1. I have 1/2, but then I have the 2 upstairs. I have a quarter of a second here for the period, but I have 4 cycles. I have 1/8 seconds for the period, but I have 8 cycles for the frequency. Can you see the pattern here? 1/16, 16. 2, 1/2. 1/2, 2. 1/4, 4. I hope that you got the pattern, that the frequency and the period, they are inversely proportional to each other. See, F equals 1/T and T equals 1/F. This kind of relationship we call an inverse relationship, an inverse relationship. When one decreases, the other increases. When one increases, the other one decreases. And for the unit of the frequency, we are going to use second minus 1 or per second, or instead of using all that, we are going to honor a physicist by the name of Hertz, and then the frequency is going to be measured in Hertz.